is Jaclyn. I'm going to talk to you about municipal waste to electricity. So the general process of turning municipal waste to electricity is where you take raw municipal waste and you put it through a shredding process, and from there it goes into a magnetic separation, where you separate the ferrous materials from the non-ferrous materials. Then it goes through a drying process to remove the remaining moisture. And then it goes through another separating process to remove high-density plastic from combustion materials. The combustible materials go to a compactor, and the end product is a fuel pellet. And then you take that fuel pellet and you put it through a boiler operation, which will create steam, and that will turn the turbine to create electricity. So the reason why this project is a benefit to our society is that if we could find a way to make this economical, they could possibly bring it to the area, it would create jobs and skilled workers. It would reduce waste in landfills, and it would create energy in the local area. But also, we have a lot of fossil plants that they're retiring, and this would be a possible way to replace the energy cost, and it would be a green way to do it. So how it relates to our studies, there's a combustion precedent, there's mass balances, energy balance, thermodynamics, and air pollution control. So what has been done, there's been research on the initial cost, and the initial cost of a plant is typically $110,000 to $140,000 per daily ton of capacity. And the reason I included that is so you guys can be aware of like the economic impact and see if it was feasible. And the average cost per kilowatt hour is approximately 37 cents. Coal and nuclear power are below 4% of kilowatt hour. And I've done some research on air pollution. It does create a lot of air pollution, so there will be a need to further study into that and find ways to reduce air pollution. And there's been some mass balances done. What needs to be done? There needs to be a waste, find a way to how we're going to get the waste to the plant and how we're going to get it going through the process, a method of transporting it, and then what to do with the excess materials not used for fuel pellets. Part of this class, as we said, when you do analysis on your process flow diagram, is to find ways to reduce waste. And right now we have ferrous materials and high-density plastic that are coming off the line that you could possibly reduce or recycle. And then materials in the plant to help reduce corrosion, and then are there health concerns, bacteria, and then air pollution. So in conclusion, I think this is really interesting. I don't know if it could be completed in a semester, and it's really interesting. It's a green project. We do have a problem with increasing waste in landfills, and this would be a way to reduce it. Do you guys have any questions?